Let's take our next question, that is question number 16. As per the question, a charged capacitor with capacitance C1 is discharged through resistor R. Capacitor with capacitance C2 is initially uncharged. When the discharge current attains the value I0, the key is shifted from position 1 to 2. The total amount of heat liberated in the resistor starting from this moment is. So, initially there was some energy stored in this C1. Then when the key is shifted to 2, some energy is being redistributed, and in that case the loss of energy would be energy in C1 which was stored before shifting minus the energy which is stored in the system after shifting the key. So let's start with the solution. Stating that V is equals to I naught R, that can be written as initial charge Q naught by C1, right? Now the initial energy in this would be Q naught square by 2C1, or I can also write this as C1 I naught R, this is whole square divided by 2, right? Now this is the first equation for me. Moving on about the second equation. So we very well know after the charge distribution the total charge remains same, and the combination is in parallel combination twice of C1 plus C2 as they are in parallel combination. If I put this value here, I will get C1 square I naught square R square divided by twice of C1 plus C2. Now you want to find the loss of electrostatic energy, that would be U1 minus U2, and that would be C1 I naught square R square divided by 2 minus C1 square I naught square R square divided by twice of C1 plus C2. Simplifying this, I will get C1 C2 I naught square R square divided by twice of C1 plus C2. So this would be the loss of electrostatic energy. Let's see which is the best suited option for same. So if we move up, you will find yes, option number 1 is the correct answer for this question. Now let's move on to our next question, that is question number 17. Now the question you see here, the resistance R of a thermal coefficient of resistivity alpha is connected in parallel with resistance 3R having the thermal coefficient of resistivity 2 alpha. The equivalent thermal coefficient of resistivity for the combination is. So before we proceed, we must know the formula for resistance and the relation between the thermal coefficient. So this would be the relation, right? From here I can also write delta R upon R naught would be equal to alpha delta theta, or alpha would be equal to delta R upon R naught into delta theta. This is one formula you should know before we proceed. Now in the parallel combination we are very well aware that 1 upon R net is equals to 1 upon R1 plus 1 upon R2. For the error method we can write delta R net divided by R net whole square would be equal to delta R1 divided by R1 square plus delta R2 divided by R2 square, right? If I multiply delta theta across on both sides, what I will get is alpha net upon R net, right? Because delta R net by delta theta into R net is alpha net. Similarly here it would be alpha 1 by R1 plus alpha 2 by R2. Now what would be the R net value? Definitely it would be R into 3R divided by R plus 3R. As we are aware that R1 is R and R2 is 3R given in the question. When you solve this you will get 3R by 4 as R net. Let's put down the values. So what you will get is alpha net upon 3R by 4 is equals to alpha upon R plus 2 alpha upon 3R. Solving this you will get alpha net is equals to 5 alpha by 4. Now let's see which is the best suited option here, friends. Among the 4 options given to us, yes, option number 4 is the correct answer. Now let's move on to our next question, that is question number 18. The question you see is a very simple question of voltmeter where the reading of voltmeter is given as 5 volt. right? The resistance of the voltmeter is, it's pretty simple that for a 10 volt, 5 volt is already here, so this would be 5 volt. That means you see this combination will hold the equal resistance as that of this 50 ohm. So it's now simple. Let's start the solution. For the combination of 100 and voltmeter in parallel, let's take this resistance as X. What you can write is 100 into X upon 100 plus X will be equal to 50. Solving this, you will get X is equals to 100 ohm. Let's see which is the best suited option here. Among the 4 options, yes, option number 2 is the correct answer to this question. I hope you have understood the question. Now let's move on to our next question, that is question number 19.